Good morning, students. Good afternoon, students. Is it audible, ma? Last class we are completed diffraction, Fresnel diffraction, and Fraunhofer diffraction and distinguishes. Now we will go for Fresnel diffraction due to single slit, ma. Due to single slit, what is the Fresnel diffraction? And Fraunhofer diffraction due to single slit. Now we want to discuss. So this one over last class, ma. Fresnel and Fraunhofer diffraction and mathematical approachment over. Now we will go for Fraunhofer diffraction due to single slit. Okay, last class we are up to here. It is completed derivation part where what it is, ma, b square by 2d delta is equal to b square by 2d that equal to b square by L that equal to lambda by 8 defines the boundary between Fresnel and Fraunhofer diffraction. B square by L is equal to lambda by 8 defines the b square by L is equal to lambda by 8 defines the Fraunhofer differences between Fresnel and Fraunhofer diffraction. Fraunhofer diffraction, what is the condition? B square by L lambda less than 1. And Fresnel diffraction, b square by L is equal to 1. Straight line propagation, b square by L lambda greater than 1. So the value of the dimensions constant b square by 2 lambda decides the type of diffraction to be seen. That is the diffraction pattern. But now we will go for Fresnel diffraction at a straight edge. Fresnel diffraction at a straight edge. So that here what it is, ma, we are considering the qualitative analysis for these conditions are over. Now Fresnel diffraction at a straight edge. So in a Fresnel diffraction at a straight edge, what we will complete continuously diffraction at a straight edge. In this unit, Fresnel diffraction at a straight edge is explained. In order to make understand, it applies the Huygens principle or Fresnel theory of diffraction to wavefront on a straight edge. After going through this, we will calculate the amplitude phase of the waves reaching the screen from elements in the wavefront, the resultant disturbance at a point on the screen. Now, mathematical treatment of diffraction at a straight edge. Mathematical treatment of diffraction at a straight edge. So here what we are considering, ma, Huygens Fresnel theory to Fresnel diffraction at a straight edge shown in a figure, ma. Here straight edge OS is extending a large distance beyond S. OS is extended a large distance beyond S, ma. That is a straight edge we are extending here. A plane wavefront is incident from the left. Its portion along OS is completely stopped by the straight edge, and the part extending along OQ and beyond it allowed what it is from the figure. Now in this figure, we are observing that theoretical approachment. So OS is completely stopped by the edge. So here we apply the, according to the figure we are explaining, a wave plane print incident from the left, its portion along OS is completely stopped by the straight edge and the part extending along OQ. That was observed in this particular diagram. Fresnel diffraction at a straight edge. Elements along OQ become hydrogen secondary sources and send the waves towards observation screen. Send the send the waves towards the observation screen C, where these secondary waves combine and produce the diffraction. These secondary waves combine and produce the diffraction pattern. The amplitude. Okay, in this diagram, the amplitude of a secondary wave from an element of length dh is situated. Dh is situated at a distance h from edge O is proportional to dh. The path difference between the waves from O and those from Q is delta is equal to h square by 2s, and the phase difference is delta is equal to 2 pi by lambda into delta, where S is the distance between O and the corresponding P at the edge of the geometrical shadow. This formula was derived in this application, so that the light disturbance reaching the point P, from Q represent by d psi is equal to dh cos omega t minus lambda. D psi is equal to dh cos omega t minus lambda. That is the light disturbance reaching the point P, where delta is equal to 2 pi by lambda h square by 2s represents the phase relative to that of the wave from the element that of the wave from element at h is equal to 0. There are several ways of mathematically dealing with the addition of such simple harmonic waves. We shall use now the vector notation. The wave described by this expression, above expression, represented by the vector length is proportional to the amplitude. Therefore, finally, what is the condition here? Phi is equal to 2 pi by lambda h square by 2s with the x-axis. The x and y components of this small vector are dx is equal to dh into cos of 2 pi by lambda into h square by 2s. Therefore, dy is equal to dh into sine of 2 pi by lambda h square by 2s. We can find the resultant due to the waves from all hydrogen secondary source in the wavefront between O and Q by integrating these expressions between O and H. Okay, that from the diagram O and Q, we have the distances H, O and S is the edge in the wave between O and Q. Now the resultant amplitude produced at the point P is equal to the length of the resultant vector or phasor R. Now R equal to under root of A square plus B square, that equal to distance OT. So the vector OT represents the resultant wave. Okay, R is equal to under root of A square plus B square. V is equal to H by under root of 2 by lambda S. So above equations, we can take that dx is equal to under root of lambda S by 2 into dv cos pi by 2 B square. Then dy is equal to root of lambda S by 2 dv sine of pi by 2 B square. Further, let us choose now x and y. So we write dx is equal to dv cos pi by 2 V square. Then dy is equal to dv sine pi by 2 V square. We will write the new variables x and y, also x and y. Then this is a analysis is complicated somewhat compared to single and double. Single and double is important. This we can observe only how to take the approachment of diffraction phenomena using straight edge. The slope of the curve at V is equal to dy by dx. Rate of change of displacement is called velocity. Then it can be equal to tan of pi by 2 V square. The angle of this slope is theta is equal to phi by 2 V square. This tells us that as v increases and the point t moves further on the curve, therefore the slope as x is equal to 0 to infinity cos pi by 2 v square dv. And then y is equal to square dv. So a symmetric point Z, final equation what we are taking ma, V is equal to V1 is equal to H1 under root of 2 by lambda s. And the second point as the before corresponds to V is equal to infinity. So the length is A. This shows clearly that as the observation point moves into geometrical shadow region. Is it audible, students?
Yes, ma'am.
Okay. Are you following?
Yes, ma'am.
Okay. You have textbooks no ma?
No,
Text,
ma'am. ఇంక
you don't have
ఇవ్వలేదు అమ్మ సెంటర్ లో.
what ma? You're not
No,
taken enough from your centers?
no, madam.
Okay. Okay. What I'm explaining that you can take screenshots ma.
Okay, madam.
Okay. Over. Now I will give you some notes. Fraunhofer diffraction due to single slit and double slit. I will give you video ma, that will take. Okay. This straight edge may somewhat complicated. Leave that choice for. Okay, next single slit and double slit are important. Fraunhofer diffraction due to next lesson. Fraunhofer diffraction due to single slit and double slit are important. Okay, straight edge means that can be taken as a choice ma. Next lesson is plane diffraction grating measurement of wavelength of light means here two types of modes is there ma. One is single slit, one is a double slit. One is single slit, one is a double slit. Okay. Now next lesson is in the same unit. Next lesson ma, what it is plane diffraction grating measurement of wavelengths of light. Two lessons completed here. Fresnel diffraction due to a straight edge, Fresnel and Fraunhofer diffraction over. Next third lesson is this is a plane diffraction grating measurement of wavelength of light. So in this we will discuss Fresnel and Fraunhofer single and double modes ma. Okay, introduction and Fraunhofer diffraction pattern of single, double and multiple slits. Okay, next here what it is ma, first one already we have studied Fresnel and Fraunhofer type of diffraction. Let us consider the diffraction pattern produced by several parallel slits of equal width be equal to speed that the distance a. Now Fraunhofer diffraction pattern of single, double and multiple slits. We want to take the single slit, double slit and multiple slits. Single slit, double slit and multiple slits we want to take. Now first we will discuss about single slit diffraction. Now I will take another. Okay, if you want take this will be take screenshot man. Next in your book you have this one. Second page. I will explain later. First you take the screenshots. next religion, next last lesson in this particular unit. Okay, now Fraunhofer diffraction due to single slit we want to take ma for that. So this is the basic differences between Fresnel and Fraunhofer diffraction. Is it visible on the screen?
Yes, ma'am.
Fraunhofer diffraction and Fresnel diffraction. If they're asking distinguishes means you can write that differences. My yesterday class we are explained that no. Next, resultant of n simple harmonic vibrations. So here we can take as consider n simple harmonic vibrations of same amplitude m, same period t, and same phase difference d between consecutive vibrations which act on a particle simultaneously. Then to find the resultant amplitude in order to construct the polygon of amplitude as shown in figure. So different types of polygon of amplitude as shown in figure. Okay, the closing side of an angle theta then gives the resultant amplitude r and phase of the resultant vibrations respectively. In order to calculate resultant r and theta, resolving the amplitudes along OA as a cos t, a cos 2d, a sin 2d, like that it will be adding 1 plus 1 number d, 2d, 3d, 4d, like that. Then up to n minus 1d, a sin n minus 1d, the horizontal component of a resultant vibration, r cos theta is given by r cos theta is equal to a plus a cos d, a cos 2d, so on up to a cos n minus 1 into d. In all the terms, a is common. R cos theta is equal to a into 1 plus cos d plus cos 2d, cos 2d plus cos of n minus 1 into d, which is equation number 1. Now further what we are taken here, the vertical component of resultant vibration. The vertical component of, is it visible ma? Is it visible on the screen? Okay. The vertical component of resultant vibration r sin theta is given by r sin theta is equal to a sin d plus, that is a horizontal component ma, horizontal component r cos theta is equal to, we are taken as a into 1 plus cos d plus cos 2d plus of cos n minus 1 into d. Here we are taken as the vertical component of resultant. Kumari, is it visible on the screen? Okay, R is equal to A sine of what we are taken, my horizontal component we are taken and vertical component we are taken. Now vertical component, what it is, ma R sine theta is equal to A sine D plus A sine 2D, so on of A sine of n minus 1D. And then A is common in all the terms. Then A into sine D plus sine 2D plus so on sine of n minus 1D. Now multiplying equation 1 with 2 sine D by 2, ma multiplying equation 1 before phase you have no our horizontal component r cos theta, that is equation 1. Now r sin theta is equation 2. Now equation 1 is multiplied with 2 sin d by 2. Then what it is, ma r LHS side you have r cos theta. R cos theta multiply with 2 sin d by 2 means it becomes 2r cos theta sin d by 2. 2r cos theta sin d by 2 is equal to A into, here also every term we can multiply with 2 sin d by 2. Then A into 2 sin d by 2 plus 2 cos d into sin d by 2. So on we can take first one, what it is, ma one term is there. A into 1 plus cos delta plus cos 2d plus of cos of n minus 1 into d, no, that is equation number 1. In that now we are multiplying with 2 sin d by 2. Then it is 2r cos theta sin d by 2. Then A into 2 sin d by 2 plus 2 cos d sin d by 2, so on. Then 2r cos theta sin d by 2 is LH side. RH side A already common. 2 sin d by 2 plus we can take sin 3d by 2 minus sin d by 2 plus on sine of n minus 1 by 2 into d minus of sine of n minus 3 by 2d. Like that we can take all the terms, two terms we can combiningly taken. Then 2r cos theta sin d by 2 is equal to 2a sin n d by 2. 2a sin n d by 2 cos of n minus 1 into d by 2. Then r cos theta is equal to a sin n d by 2 by sin d by 2 into cos of n minus 1 into d by 2. Similarly r sin theta, so like first you are taken as horizontal component r cos theta value, that is equation number 3. Similarly we can do multiply with 2 sin d by 2 for both the equations. Then r sin theta is equal to a sin n d by 2 by sin d by 2 sin of n minus 1 into d by 2. If you are observing equation 3 and 4, only one difference is there, ma. A sin n d by 2 by sin d by 2 same as usual. Above third equation you have cos, in fourth equation you have sin. Now squaring equations 3 and 4 and adding, squaring equations 3 and 4 and then adding, then what it is, ma r square sin square theta plus r square cos square theta. That equal to what it is, ma RH side a square sin square n d by 2 by sin square d by 2 cos square n, squaring and adding both LHS and RHS. Then what happened, ma r square cos square theta plus r square sin square theta. Equation 3 squaring add and equation 4 also squaring and adding both LHS and RHS. Then LHS r square is common, cos square theta plus sin square theta. Then that LHS RHS side we have a square sin square n d by 2 by sin square d by 2 into cos square n minus 1 d by 2 plus sin square n minus 1 into d by 2. So what happened, ma? That value equal to 1. Cos square of n minus 1 into d by d plus sin square of n minus 1 into d by 2. Here sin square theta plus cos square theta value 1. Then what I have finally equation? R square is equal to a square sin square n d by 2 by sin square d by 2. Okay, ma. That is the resultant value, r value. R is equal to under root of, no, r is equal to under root of means what it is, ma? A sin n d by 2 by sin d by 2. R is equal to a sin n d by 2 by sin d by 2. Next we are getting that one. To this it is clear, students? Multiple reflections, if a resultant of n simple harmonic vibrations or motions, what is the diffraction phenomena? How to calculate the resultant value? Resultant value is equal to r square a square sin square n d by 2 by sin sin square d by 2. Ma, if you are removing all the squares, you have just r is equal to a sin n d by 2 by sin d by 2. Okay, this one. R is equal to A sin ND by 2 by sin D by 2, which is equation number 5. Now you are doing equation 4 by equation 3. Before what you are doing was squaring and adding. Now we are taken as ratio. R sin theta by R cos theta is equal to, what is R sin theta value? Sin of n minus 1 into D by 2. And cos theta value, R cos theta value cos of n minus 1 into D, no? Only that is the difference. Now ratios we are taken means 4 by 3, R sin theta by R cos theta. R gets cancelled. Sin theta by cos theta means tan theta. Then sin by cos means tan of n minus 1 into D by 2. Now both sides tan is removing. Then theta is equal to n minus 1 into D by 2. So resultant value for n vibrations are interfere one another. Then diffraction phenomena was observed for n simple harmonic vibrations. In that you are calculating resultant value is equal to A sin ND by 2 by sin D by 2 and angle theta equal to n minus 1 into D by 2. Okay, ma? Are you followed, students? That is n number of vibrations. Now we are taken for Fraunhofer diffraction due to single slit. Very, very important, ma. Fraunhofer diffraction due to single slit. So in this figure is also very, very important. Here consider a plane wave front of width W dash, ma. Okay, and it goes passing through a lens, and finally on the screen we can observe the diffraction phenomena in the shadow region, the bending, the light ray passing from the shadow or obstacle on that particular region, how the behavior of light, that is nothing but diffraction. So that Fraunhofer diffraction, already we know that what it is, screen, slit, source are at what distance it is there. Just now we are taken as distinguishes, no? In Fraunhofer diffraction, infinity distance. In Fresnel diffraction, source and screen are finite distance from the obstacle. In Fraunhofer diffraction, what it is, ma? The wave fronts are incident on obstacle in the form of plane wave fronts. The wave fronts incident on obstacle in the form of cylindrical or spherical wave fronts. In Fraunhofer, lenses are used for making rays are parallel. So that in Fraunhofer diffraction, here also we are using one lens. For that, now we are explaining Fraunhofer diffraction due to a single slit. Here consider a plane wave front W dash, that number of rays are passing like that, 1, 2, 3, 4, so on. Monochromatic light of wavelength lambda, light wavelength lambda, propagating normally to the narrow slit, AB of width E. The slit width is E, that slit is AB, normally to the narrow slit AB of width E, perpendicular to the plane of the paper, as shown in that particular diagram. According to Huygens theory, each point of the wavefront, each point of the wavefront in the plane of the paper or slit is a source of secondary spherical wavelet. Okay, Mike. Huygens theory, what it says, ma? Every particle on the slit or source of light is acting as the secondary wavelet, secondary spherical wavelet, and also spreads out the light in all directions. Last class we discussed Noma Huygens wave theory means on the wave, every particle again act as a secondary wavelet. Here also same, spread out in all directions. These secondary wavelets travel in the direction normal to the slit or focused at P0 while the secondary waves propagating at an angle theta, with the normal or centered at point P1 on the screen. Okay, ma. Secondary wavelets propagating at an angle theta with the normal are centered at point P1. Primary is focusing at a point P, and secondary wavelets focusing at a point P1 on the screen. Is it clear? Primary source and secondary source, every particle or each point of the wavefront in the plane of the slit is a source of secondary spherical wavelets and also spreads out in the directions. No, these secondary wavelets travel in the direction normal to the slit are focused at P naught, while the secondary wavelets propagating at an angle theta with the normal are centered at point P1. Primary is P naught and secondary wavelets touches at a point P1 on the screen. Thus, the point P1 is of the minimum intensity. The point P1 is the minimum intensity or maximum intensity, depending upon the path difference between the secondary waves originating from the respective points of the wavefront. Now, where it is maximum intensity, where it is minimum intensity on the screen, we want to take the path difference consideration. To calculate the intensity at point P1, if you want to calculate at what band is formed, intensity value is maximum or minimum. If you want to calculate that, you draw a perpendicular AC on BR in the figure. Okay, ma. AC perpendicular drawn on BR, hence the path difference between secondary wavelets. Then hence the path difference between first wave and secondary wavelets, what it is, ma? Only BC. First one is AB slit. From that only it is moving. First wave and second wave, what is the difference? Just BC only. Okay, the path difference between first primary wavelets and secondary wavelets, how much it is? Only BC. Okay. From the triangle, what it is, ma? Sin theta. Sin theta is equal to what it is, ma? Opposite side by hypotenuse. Using that formula here, AB sin theta. What is AB, ma? Slit width E. Initially we are considering slit width is E. Therefore, instead of AB, now we are substituting E sin theta. Sin theta is equal to BC by AB. Then BC is equal to AB sin theta. BC is equal to AB sin theta. BC by AB is nothing but sin theta. Ma. Then BC is equal to AB sin theta. AB is nothing but slit width, that equal to E. E sin theta. Phase difference is equal to what it is, ma? 2 pi by lambda into path difference. Phase difference is equal to 2 pi by lambda into path difference. 2 pi by lambda as usual. But above equation, what is the path difference? E sin theta. Therefore, phase difference is equal to 2 pi by lambda into E sin theta. If the width of the slit is divided into, n equal parts, okay, if the width of the slit is divided into n equal parts and the amplitude of the wave from each part is A, and the amplitude of the wave from each part is, okay, ma? If the width of the slit is divided into n equal parts and the amplitude of the wave from each part is A, therefore phase difference between any two successive waves is equal to 1 by n into 2 pi by lambda into E sin theta. Okay, phase difference between any two successive waves is equal to 1 by n into 2 pi by lambda into E sin theta, that is equal to small d. Therefore, the resultant amplitude at P1 is given by the resultant 1 by n into 2 pi by lambda E sin theta is phase difference. 2 pi by lambda E sin theta is general. For n number of waves are propagating, means the phase difference between two successive waves is 1 by n 2 pi by lambda E sin theta, that equal to d, that equal to small d. Therefore, the resultant amplitude at P1 is given by, so resultant value already we taken before, A sin R is equal to A sin ND by 2 by sin D by 2. Now, instead of D, you are substituting this value, 2 pi by n lambda E sin theta. That formula we are substituting in above resultant equation and angle. We are calculating Fraunhofer diffraction due to single slit. Before derivation, we are taken as R is equal to A sin ND by 2 by sin D by 2. Now, instead of D, you are substituting this value, 2 pi by n lambda E sin theta. Then the equation becomes, okay, the above equation becomes R is equal to A sin ND by 2. So A sin ND by 2 means now instead of D, what you are substituting, this pi e by lambda sin theta. before d value are substituting here, then the equation becomes d is equal to 1 by n 2 pi by lambda e sin theta, and r is equal to a sin nd by 2 by sin d by 2. 2 gets cancelled. Then final equation becomes r is equal to a sin pi e by lambda, a sin pi e by lambda sin theta by sin pi e sin pi e by n lambda sin theta. Now alpha instead of pi e sin theta by lambda, we can take as alpha. Instead of pi e sin theta by lambda, we are taken as alpha. Therefore, r is equal to a sin alpha by sin alpha n. Then take that value alpha by n is very small. Sin alpha by n is equal to alpha by n. Therefore, r is equal to a sin alpha by sin alpha by n. So instead of the two values substituting in that, we are getting final equation is r is equal to a sin alpha by n. Now this n take upwards, na sin alpha by alpha. Capital R equal to na is nothing but capital A. So n multiple number of waves are propagating means na is nothing but total amplitude a sin alpha by alpha. If n tends to infinity, a tends to 0. If n is taken as multiple number of waves, means amplitude of each wave will be 0. Then na is equal to, we are taken as capital A. Therefore, intensity I is equal to r square. Intensity I is equal to r square. Instead of r, we are substituting here a sin alpha by alpha whole square. Then ab whole square means a square b square. Here we are taken as a square sin square alpha by alpha square. Then I is equal to, what it is my intensity value, I is equal to I naught sin alpha by alpha whole square. R is equal to a sin alpha by alpha, and I is equal to r square. Then it becomes a square sin square alpha by alpha square. Then this can be taken as I is equal to I naught sin alpha by alpha whole square. Okay, this is the intensity formula at point P1. Now intensity positions, where it is maximum and where it is minimum. At point P1, P0 is there. Number P1 is secondary wavelets and P0 is primary wavelets on the figure. Now we are taken for principal, where it is intensity, how it is varies. Now we are calculating for where it is maximum, where it is minimum. The maximum which corresponds to theta is equal to 0 is called principal maximum. The maximum which corresponds to theta equal to 0 is called principal maxima. Therefore, R is equal to A sin alpha by alpha. A by alpha is common. Instead of sin alpha, we are taken as formula alpha minus alpha cube by 3 factorial plus alpha 5 by 5 factorial minus alpha 7 by 7 factorial, so on. In all the equations, we are taken as alpha common and alpha cancel. Numerator and denominator, you have alpha is there, cancel each other. You have R is equal to a into 1 minus 1 alpha is removing means alpha cube becomes alpha square, alpha 5 becomes alpha power 4, 7 becomes 6, like that. Then R is equal to a into 1 minus alpha square by 3 factorial plus alpha power 4 by 5 factorial, so on. Therefore, for maximum intensity, R maximum, alpha becomes 0. Therefore, what is alpha? Initially, we are taken as alpha is equal to phi e sin theta by lambda. Here, alpha is equal to phi e sin theta by lambda. Okay, now alpha is equal to maximum in intensity means resultant means alpha equal to 0. Then pi e sin theta by lambda equal to 0. So that here what it is, pi e by lambda is not equal to 0. Pi e by lambda is not equal to 0. Only sin theta is equal to 0. Then when it is sin value 0, theta is equal to 0 only, it is 0. Therefore, sin theta is equal to 0 means theta is equal to 0. That particular situation, intensity will be first maximum. Okay, that is the first maxima position, principal maximum, which is known as principal maximum, which is known as principal maximum. When theta is equal to 0, we are getting principal maximum. Next, secondary maximum. intensity position, minimum intensity, maximum intensity position, first and second we are considering. Now minimum intensity position for second, and then how the graph will be varying. Okay, ma. Now first maximum where it is ma, sin theta is equal to 0 means theta is equal to 0. We are getting the principal maxima. Now we are taken as secondary maximum. Secondary maximum means for secondary maximum, what it is ma, differentiating of I with respect to alpha. Di by d alpha is equal to 0. Di by d alpha is equal to 0. Therefore, d by d alpha of what is I? A square sin square alpha by alpha square. Now you are substituting that value equal to 0. Now differentiating with respect to alpha, then what it is ma, 1 a square is UV method. Using UV method, we can differentiating a square is into 2 sin alpha by alpha. Then alpha cos alpha minus sin alpha by alpha square is equal to 0. Then sin alpha is equal to 0. Or alpha cos alpha minus sin alpha is equal to 0. Then what it is ma, alpha cos alpha is equal to sin alpha. Then alpha is equal to sin alpha by cos alpha, that equal to tan alpha. Alpha is equal to plus or minus 3 pi by 2 comma plus or minus 5 pi by 2. Okay, this particular situations we are getting the secondary maximum. First one is theta is equal to 0. Second, alpha is equal to plus or minus 3 pi by 2 plus or minus 5 pi by 2, so on numbers. We are getting the secondary maximum. And then minimum intensity position, and then minimum intensity position. Here for minimum intensity, sin alpha is equal to 0. Then instead of 0, what you are taken as sin of plus or minus n pi, sin of plus or minus n5. Therefore, alpha is equal to plus or minus 5, plus or minus 2 pi, plus or minus 3 pi we are taken. So then intensity maximum and minimum intensity graph was shown in figure now. Okay. Here center one is 0, then positive side and negative side. Pi by 2, 3 pi by 2, pi by 2. We can take as pi, 2 pi, so on. Here y is equal to alpha and y is equal to tan alpha. Touches at that particular point O. So at 45 degrees, this side we can take as minus pi by 2, minus 3 by 2, minus 5 pi by 2, so on. Now, intensity distribution graph for single slit diffraction, Fraunhofer single slit diffraction. Figure shows the graph intensity distribution, and how the intensity vary with alpha. How the intensity vary with alpha was shown. The diffraction pattern consists of a central principal maxima. Subsidiary maxima are decreasing intensity and minima. And we can observe from the graph, the subsidiary maximum do not fall exactly midway between two minimum. So this what it is, it is consecutively decreases on both sides, and positive side and negative side. It gives continuously maximum and minimum, maximum of decreasing intensity and minimum was shown in this particular diagram, which is the Fraunhofer diffraction due to single slit. Fraunhofer diffraction due to single slit. Okay, ma'am. Is there any doubt, students? intensity distribution curve, Fraunhofer diffraction. Next, we'll go for Fraunhofer diffraction for circular aperture. And then double slits. Is there any doubt? Next, we'll go for Fraunhofer diffraction due to circular aperture. So here what we are taken Fraunhofer diffraction due to circular aperture means here also same slit circular aperture we want to consider consider a plane wavefront W dash of a monochromatic light of wavelength lambda. Okay, consider a plane wavefront like there 1, 2, 3, 4 waves light rays are propagating through W dash window. No, same way here also consider a plane wavefront W dash of monochromatic light of wavelength lambda propagating normally to the circular aperture of diameter D. Before one is slit width E, here we can take it as D as shown in figure. So according to Huygens theory, every point of the wavefront in the plane of circular aperture is a source of secondary wavelets which spread out the right and wavelets traveling along the normal to the circular aperture come to focus at P0. Okay, ma. The circular, the waves which are spread out to the right and the wavelets traveling along the normal to the circular aperture come to focus at P0 and corresponds to the position of central maximum, while the secondary waves traveling in a direction inclined at an angle theta with normal to the aperture come to the focus at P1 on the screen. Let x of P0, P1 be distance between P0 and P1. Okay, ma. Same as before, single slit, how it is locating at different situations. Primary is P0 and secondary is P1. Like that, here also P0 and P1 with the certain path difference between the waves A and B is equal to AC. So before we can take the just path difference is BC. Here difference is AC. Above we are considering for circular aperture. From the triangle ACB, AC is equal to AB sin theta. AC is equal to sin theta is equal to AC by AB. Then AC is equal to AB sin theta. AC only, but AB is nothing but D. Before we can take as E sin theta. Now here it is D sin theta. AC is equal to D sin theta. Similarly to a single slit, the point P1. The point P1 is of the maximum intensity if the path difference is an odd multiple of lambda by 2 and of minimum intensity if the path difference is an integral multiple of lambda. Then D sin theta is equal to 2n plus 1 into lambda by 2. D sin theta is equal to 2n plus 1 into lambda by 2. That is maximum. And D sin theta is equal to n lambda, that is minima, where n is equal to 1, 2, 3, so on. Okay, when it is maximum and when it is minimum, D sin theta is equal to 2n plus 1 into lambda by 2 is maximum and minimum intensity is D sin theta, that width is equal to n lambda means minimum, where n is equal to 1, 2, 3. Therefore, the case of circular aperture, the diffraction pattern is surrounded by discs and rings known as Aries discs or Aries rings respectively. the corresponding wavelengths for this particular Fraunhofer diffraction is different discs, which are called as Airy's rings or Airy's discs. Therefore, if the lens is placed near the aperture, if the lens is placed near to the aperture or the screen is far away from the lens, then sin theta is equal to x by f. Then sin theta is equal to x by f. Substitute equation 3 in above equations, equation 2. Then what it is, d sin theta is equal to n lambda. D into, in the place of sin theta, now we are substituting x by f. D x by f is equal to n lambda. If n is equal to 1, what happened, x by f is equal to lambda by d. X by f is equal to lambda by d, n is equal to 1. Then x is equal to how much, f lambda by d. LCM you are doing. Then x is equal to f lambda by d. X by f is equal to lambda by d. Then x is equal to f lambda by d. So one and all equations, above equations 1, 2, 3, and fourth equation is x is equal to f lambda by g. Okay, ma. Now what it is, ma? We are substituting that focal length value that equal to x is radius of the Aries disc. X is nothing but what is x here? Different circles or rings we are taken. That radius of the disc is x. Therefore, according to Airy, the exact value of x is given by 1.22 f lambda by d. 1.22 f lambda by d. Okay, exacting to Aries disc, we can take as x is equal to 1.22 f lambda by d, which is radius of the Aries disc, which is the radius of the Aries disc. Now we'll go for Fraunhofer diffraction due to double slit. Ma. Okay, single slit over and circular aperture over. Now next we will discuss about Fraunhofer diffraction due to double slit. For this diagram is this one. The diagrammatic representation of Fraunhofer diffraction due to double slit is shown in this particular figure. Consider two parallel slits AB and CD. So before figure we have taken only one single slit, Noma. Here we can take as AB, S1 is one slit and CD, S2 is second slit. Okay. The diagrammatic representation is shown in figure. Are you following? Now Fraunhofer diffraction due to double slit we are taken. For that, the diagram is shown in on the screen. Now consider two parallel slits AB and CD. AB and CD equal width E and separated by a opaque distance D. These two are separated by the distance small d. The distance between the corresponding middle points of the two slits is E plus D. Okay, ma. One is E, one is each slit width is E and separated by the distance is D. Then the middle point to another middle point, what is the distance? E plus D. Let a plane wavefront of monochromatic light of wavelength, light lambda, be incident normally on the two slits. The secondary waves traveling in the direction of incident light. Come to focus at point P0. Okay, same as before also P0 and P1 we are taken. No, here also same. Plane wavefront monochromatic of length, wavelength lambda, incident normally on the two slits. The secondary waves traveling in the direction of incident light come to focus at point P naught, while the secondary wavelets traveling in a direction making an angle theta with the incident direction. With the figure we have the light source to lens, width is E plus D and is touches to the primary, it touches the point P naught, and secondary wavelets with making an angle theta which touches the point P1. Now we know that according to the theory of diffraction at a single slit, the resulting amplitude R for the wavelets diffracted from each slit in a direction theta is given by R is equal to A sine alpha by alpha, where A is nothing but amplitude, alpha is equal to pi e sine theta by lambda. Alpha is equal to pi e sine theta by lambda. In order to calculate the path difference between the wavelets S1 and S2, the two slits treated as two sources S1, that particular two slits can be taken as two sources S1 and S2 of each source sending a wavelet of amplitude A sine alpha by alpha in a direction theta. Hence, the resultant amplitude at a point P1 will be the result of interference between the two waves. So here two waves are coming from two sources of identical sources. These two sources S1 and S2 act as the two coherent sources. From this two waves are superimpose each other and give the interference phenomena between the two waves of amplitude A sine alpha by alpha and a phase difference delta. We draw a perpendicular S1K and S2K. S1K, if you want to calculate resultant value, we draw on perpendicular S1K on S2K. Observe figure also. The path difference between the wavelets is S2K. Now, what is the path difference between first wave and second wave is only S2K. Before also we can take single slit is BC, a double slit is AC, and this Fraunhofer diffraction due to circular aperture is AC, and this Fraunhofer diffraction due to double slit is S2K according to the diagram representation. The path difference between the wavelets S2K is equal to S1 S2 sine theta. Using the triangle S1 S2K triangle, S1 S2K triangle, S2K is equal to S1 S2. Sine theta is equal to S2K by S1 S2. And you want to find out S2K means S1 S2 value how much? S1 S2 how much distance is there? E plus D. Okay, S1 S2 value instead of S1 S2, what is the distance? E plus D sine theta. From the diagram also it is clear, no? That E plus D is equal to distance between S1 and S2 middle points. Therefore, S2K is equal to E plus D sine theta. The phase difference delta is equal to 2 pi by lambda E plus D sine theta. From figure 2, so we are calculating figure 2, what it is, triangle. A sine alpha by A sine alpha and A sine alpha by alpha is two sides. Then the resultant value using by Pythagoras theorem, what it is, OH square is equal to, here what OH, OG and GH is there, no? In this diagram we can take as OH, GH and OG. Now OH square is equal to what you are taken, OH square is equal to OG square plus GH square plus 2OG GH cos delta. Resultant value in parallelogram law of vectors we are taken R square is equal to P square plus Q square plus 2PQ cos theta. Instead of theta, here we can take it as delta, and the sides are A sine alpha by alpha and A sine alpha by alpha. Now substituting that OH is nothing but resultant R. Now we are taken that value, resultant value, using that parallelogram law of vectors or resultant equation in parallelogram law of vectors. Only few minutes, ma. So then instead of OH means R. From the triangle, we are substituting OH is equal to R and OG is equal to A sine alpha by alpha whole square and GH is A sine alpha by alpha whole square plus 2 OG GH cos 2 OG means A sin alpha by alpha and GH also A sin alpha by alpha cos delta. Then common in all the equations A sin alpha by alpha whole square. Then it becomes 1 plus 2 cos delta. Then 1 plus 1 means 2, 2 plus 2 cos delta. Then 2 common means 1 plus cos delta. Therefore, R square is equal to 2 A sin alpha by alpha whole square 1 plus cos delta. Then R square is equal to 2 into A sin alpha by alpha whole square. Instead of 1 plus cos delta, mathematical formula is 2 cos square delta by 2 minus 1. 1 as usual. Cos square theta plus sin square theta is equal to 1. No, from that cos delta value we can take as 2 cos square delta by 2 minus 1. Then 2, then plus 1 minus 1 cancel. 2 cos square delta by 2 into 2 means 4 cos square delta by 2. A sin alpha by alpha whole square only. Then it becomes 4a square. AB whole square means a square b square. Then a sin alpha by alpha whole square means a square sin square alpha by alpha square. Therefore, R square is equal to 4a square sin square alpha by alpha square cos square. Instead of delta, what it is, finally delta value can taken as 2 pi by lambda. Above equation 1 you have no before page 2 pi by lambda e plus d sin theta. Now instead of that delta we are substituting that pi 2 pi by lambda e plus d sin theta. Here also delta by 2 means the 2 gets cancelled. You have finally R is equal to 4a square sin square alpha by alpha square cos square beta. Instead of beta, here you can take as delta by 2 that equal to pi by lambda e plus d sin theta. Delta value 2 pi by lambda e plus d sin theta. The 2 take this LHS side means delta by 2 is equal to pi by lambda e plus d sin theta. So that will be taken as beta, another letter. Therefore, R square is nothing but I. Intensity distribution in a double slit experiment. I is equal to 4 I naught. A square means I naught. I is equal to 4 I naught cos square beta sin square alpha by alpha square, which is a resultant equation, intensity equation in a Fraunhofer double slit experiment. The resultant intensity at any point on the screen is the product of cos square beta and a square sin square alpha by alpha square. A square is nothing but initial intensity I naught. Therefore, the diffraction term sin square alpha by alpha square gives the central maximum. Sin square where it is maximum and minimum. Again, distribution curve also is there in double slit experiment. Sin square alpha by alpha square gives the central maximum. In the diffraction, I am making an angle theta is equal to 0, having alternating maximum and secondary maximum, and decreasing intensity on either side of as shown in figures. For maximum, alpha is equal to plus or minus m5, where m is equal to 1, 2, 3, so on. And alpha is equal to plus or minus 5, 2 pi, so on 3 pi means we can take as pi. What is alpha value? Pi sin theta by pi by lambda sin theta is equal to plus or minus m5. We can take as maximum. And E sin theta is equal to plus or minus m lambda. Then cos square beta is equal to 1, beta is equal to plus or minus n lambda. Okay, continuation, we are taking this one. Okay, E sin theta is equal to plus or minus m lambda, and sin square beta is equal to 1. Then beta is equal to plus or minus n pi. Pi by lambda E plus d sin theta is equal to plus or minus n pi. So that for secondary maximum, alpha is equal to plus or minus 3 pi by 2, so on. Then the graphical representation will be taken into okay. Now we will continue next class. Okay.